Welcome to the second topic on factors. By simple definition, a number that divides into a second one is called a factor of the second one. Thus, a number is a factor of itself. 1 is a factor of all numbers. For example, 8 divided by 4 is equal to 2. Thus, 4 is a factor of 8. Similarly, 2 divides into 8 completely, and it is therefore a factor as well. All the factors of 8 are 1, 2, 4, and 8 itself. A number that has more than 2 factors is called a composite number. For example, 4, 6, 9, 10, 12, etc., etc. Note that a prime number has 2 factors only, that is 1 and the number itself. Let's change a gear briefly and look at prime factorization. Prime factors of a number are those factors that themselves are prime numbers. Every composite number can be expressed as a product of only prime numbers. For example, 120 can be expressed as a product of its prime numbers. To start with, 2 divides into 120 60 times. Therefore, we have 2 times 60. 60 divides into 2 as well 30 times. So we have 2 times 2 times 30. Still, 30 divides into 2 15 times. So we have 2 times 2 times 2 times 15. Finally, 15 divides into 3 5 times. So finally we have 2 times 2 times 2 times 3 times 5. This can be simplified as 2 cubed times 3 times 5. An alternative method can be used to work in form of a tree diagram. This is illustrated below. By looking at that tree diagram, you will see 120 dividing into 2 60 times, 60 dividing into 2 30 times, 30 dividing into 2 15 times, and then 15 dividing into 3 5 times. Similarly, 240 can be prime factorized as follows: 2 times 120, then 2 times 2 times 60, 2 times 2 times 2 times 30, all the way until we have 2 raised to power 4 times 3 times 5. It can also be expressed in form of a tree diagram as in the case above, which is illustrated below. Do not confuse between factors and prime factors. Remember, factors are all numbers that can divide into another larger number without a remainder. On the other hand, prime factors are those factors that are prime numbers. Hence, we can say that all prime factors are also factors of a number, but the reverse is not necessarily true. Let us take another example. List all the factors of the following numbers: 80 and 100, and hence express each as a product of its prime factors. In our solution, the factors of 80 are 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. When expressed as a product of its prime factors, we have 80 dividing into 2 40 times, 40 into 2 20 times, 20 into 2 10 times, and 10 into 2 5 times. Thus, 80 as a product of its prime factors is 2 raised to power 4 times 5. Similarly, the factors of 100 are 1, 2, 4, 5, 10, 20, 25, 50, and 100. When expressed as a product of its prime factors, we have 100 divided into 2 50 times, 50 into 2 25 times, and 25 into 5 5 times. Therefore, we have 2 squared times 5 squared. Let us now look at an important application of prime factorization and factors in what is termed as greatest common divisor and least common multiple. We have seen how numbers can be expressed as products of their prime factors. We have also seen the factors of a number. This knowledge is important in finding the GCD and LCM. Let us start with the GCD. Given two or more numbers, the factors that appear in all cases are called common divisors. From our previous example, we saw the factors of 80 and 100 as shown below. The factors 1, 2, 4, 5, 10, and 20 are common to both 80 and 100. Confirm that. We therefore say that 1, 2, 4, 5, 10, and 20 are common divisors of 80 and 100. The GCD, just as the name suggests, is the largest of the common divisors. It is also called highest common factor, abbreviated as HCF. The GCD of 80 and 100 is therefore 20. We can as well use prime factorization method to find the GCD of two or more numbers. We have seen that 80 and 100 expressed in their prime factors are 80 is 2 raised to power 4 times 5, whereas 100 is 2 squared times 5 squared. If you look at these expressions, 2 times 2 is common in both 100 and 80. Similarly, a single times 5 is common. Therefore, the GCD is obtained by taking the product of the common prime factors, that is 2 times 2 times 5, which gives us 20. In another example, we can find the GCD of 120 and 240, expressed as the product of their prime factors. 120 is 2 raised to power 3 times 3 times 5. 240 is 2 raised to power 4 times 5. The common functions are 2 times 2 times 2, 3, and 5. Hence, the GCD of 120 and 240 is 2 times 2 times 2 times 3 times 5, which is equal to 120. Let us look at LCM. If a number A is a factor of another number B, then B is a multiple of A. For example, 80 is a multiple of 1, 2, 3, 4, 5, 8, 10, 16, 20, and 80. Similarly, 100 is a multiple of 1, 2, 4, 5, 10, 20, 25, 50, and 100. The multiples of 3 are 3, 6, 9, 12, 15, and the list is endless. Those of 4 are 4, 8, 12, 16, and the list is also endless. Therefore, a number has unlimited multiples. A common multiple of 2 or more numbers is that multiple that occurs in both lists. For example, 12 and 24 are common multiples of 3 and 4. The LCM is the smallest of all the common multiples. Therefore, the LCM of 3 and 4 is 12. We can also find the LCM of a group of numbers by prime factorization method. For example, find the LCM of 40 and 210. If we express them as prime factors, we have 40 is equal to 2 raised to power 3 times 5. 210 is equal to 2 times 3 times 5 times 7. The LCM is the product of all factors that appear, taking only those with highest power. That is 2 cubed times 3 times 5 times 7, which gives us 840. The LCM of 80 and 100 can also be worked out using the prime factorization method. As a product of their prime factors, 80 and 100 can be represented as shown below. The LCM following the same procedure will therefore be 2 raised to power 4 times 5 raised to power 2. Attempt as many questions as possible to ensure you differentiate between the two concepts, that is GCD and LCM. Let's look at one real-life situation that would lead a student to determine one of these concepts. A man had 3 pieces of land measuring 20, 30, and 40 hectares. He wanted to divide the land amongst his children into equal shares. What is the largest possible size that each child would get? If indeed the children got the largest possible pieces, how many children did the man have? In our solution, the idea to capture is that the share is not only equal but the largest possible. Hence, we find the GCD of 20, 30, and 40. Using any of the above methods, the GCD is 10. It means that each child can get a share of 10 hectares. For section B, if this happened, we can get the number of children by finding the total amount of land, that is 20 plus 30 plus 40, and dividing this by 10. Therefore, the man had 90 over 10 children. Let us take another example. 4 bells ring at intervals of 15, 20, 30, and 35 minutes. If they all rang at 7:40 a.m., what time will they ring together again? In our solution, we first find after how many minutes they ring together. This will be done by finding the LCM. The LCM of 15, 20, 30, and 35 is 420. This is equivalent to 7 hours. The bells will ring again at the same time after 7 hours, which when you add to 7:40 a.m. will give you 2:40 p.m. Let us now go to the divisibility test. Look at the following numbers and expressions. Do you notice something interesting? Have you identified a unique pattern? It is intriguing. These are some of the wonders in the world of mathematics that are beyond comprehension. The divisibility test will show you more about how theoretical mathematics can be. Let's see the divisibility by 2. Consider the following numbers. Looking at these numbers, all of them are even numbers, and hence they are divisible by 2. In conclusion, we say that a number is divisible by 2 if it is an even number. It can also be said that a number is divisible by 2 if it ends with 0, 2, 4, 6, and 8. Divisibility by 3. Consider the list of numbers below. All these numbers are divisible by 3. You can confirm that using your calculator. The number have a unique feature in that the sum of their digits is divisible by 3. Look at 51. 5 plus 1 is 6. For 63, 6 plus 3 is 9. For 18,372, the sum of those digits is 21. In summary, a number is divisible by 3 if its digital sum is divisible by 3. Divisibility by 4. Again, consider the numbers below. Confirm with your calculator that all of them are divisible by 4. In these numbers, the last 2 digits are either 0, 0 or form a number that is divisible by 4. That is 72, 20, 84. In summary, a number is divisible by 4 if the last 2 digits form a number that is divisible by 4 or are 0, 0. Divisibility by 5. A number is simply divisible by 5 if the last digit is 5 or 0. Divisibility by 6. Take a keen look at the list of numbers below. All of these numbers are divisible by 6. Secondly, all these numbers are even, which means they are divisible by 2. Finally, their digital sum is divisible by 3. You can confirm that. In simple terms, a number is divisible by 6 if it is divisible by both 2 and 3. Divisibility by 8. Look keenly at the four numbers below. If you try, these numbers are divisible by 8. Now, test the last three digits of each number and confirm that it is divisible by 8. Yes, it is. A number is divisible by 8 if the last three digits are 000 or form a number that is divisible by 8. Divisibility by 9. Just like the case of 3, if you create numbers that have 9 as a factor, you will find that the digital sum is divisible by 3. And finally, divisibility by 10, as any ordinary mind would know. A number is divisible by 10 if it ends with a 0.
The second thing I love about math is it's a puzzle-solving kind of, if I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it, the challenge of trying to get it. It's that puzzle-solving kind of thing that I really, really like.